Hello, Mrs. Wilson and Mr. Baker. If you recall in my interview, I mentioned that the one thing that I wish I were better at is computer technology. As I was with a few coworkers yesterday, I told them that I may be responsible for the coronavirus. The reason I feel that way is because I believe God has a sense of humor, and like it or not, I am being thrown into the world of computer technology with the stay-home lessons that we are going to have to produce. With the help of my son, I am going to explain the lesson that explains why there are either one solution to systems of equation, no solutions to those equations, or infinite amount of solutions to the equations. Before I do that, however, I would like to show you a couple of entries that are from the journal that I have been working on this year with my students. And the last one that I show you would be one that I would have done in my class with 7th and probably 8th graders to explain to them the basics of slope, how to find it, what it looks like, etc. So this is my journal from this year. And as you can see, we go through the year. We have many lessons. We do not write in this every day. We do it when they're learning something brand new. In here is a general lesson on the differences between prime and composite numbers that we work through. A second one here is a journal entry where I taught coordinate graphing for the first time for the kids, so they had no prior knowledge to this. There's a foldable that is included and explains more in depth how to graph on the Cartesian coordinate system. A sample that I might have done with the junior high kids is this journal entry that I found that explains definition, the methods for finding slope, what the slope formula is, and the 4 types of slopes that you can have. Mr. Baker, I hope you're not making fun of me at this point for my coloring. For kids that are too cool to color, we can just leave it black and white, but I enjoy coloring. Before I start the actual lesson, I would also like to show you a poster as an example of something that I would have drawn up and had hanging in my room after giving a lesson such as this. And I'll leave those posters up as a constant reminder of the things that we have learned throughout the year. So here's an example of a poster that I would have made for way back at the beginning when we first started talking about slope. There are 4 types of slope. So on each of the coordinate graphs, there are 2 points for each line that have been identified. And the kids will know that you take the change in the y over the change in the x to find the slope. When the line is going up in an upward direction, it is called a positive slope. When your slope is negative, it will be going down. If your slope is completely horizontal, it's called a 0 slope. And if the line is completely vertical, it's called an undefined slope. This is just one example of something that could be hanging in the classroom to help the kids remember what they're learning. So this would be an example of a lesson that I would go through. Ideally, you would not be looking at my notes. I would be writing them with the class as I'm going through the material. But for the sake of time and delivery, I have written out what I would say, and I'm just going to go through that briefly with you. So the table of contents would have systems of equations. We would go to our journal page and we would write the definition. The definition of systems of equations means that you have 2 or more equations with the same set of variables. For example, y equals 4x and y equals 4x plus 2. With systems of equations, there are three possible solutions, or outcomes, if you will, to any system of equations, and that's what the kids would be learning today. We're going to find that if the lines intersect, there is only one solution. If the lines end up being parallel to one another, there are no solutions. And if the lines are the same, there are infinite amount of solutions. At this point, I would then begin showing them examples so that they can see, once they graph particular equations, how they look on the graph, and then they can determine which of these three solutions they just found. In this first example, with my y equals x minus 1 and y equals 2x minus 2, I used the substitution method, and I chose numbers to plug in for the x, which gave me my y. And as I worked 3 for each, this is not a magic number, but I just like to do 3. As I worked through them, I found that they do have one point in which the lines would cross themselves. They intersect. And so I would graph it after I had explained the problem with them, and then they can see that right here is the one solution for both equations. Then I would move on to the next example that I have. This one is a little bit more complicated, as you can see. This one involves fractions, so hopefully we have a good knowledge on how to use fractions in equations. I do the same process again. I use the substitution method. I pick out various numbers for the x. That in turn shows me what the y would be. And when I had tried using the substitution method all 3 times, I did not come up with a single solution. At that point, I decided to go ahead and graph what I had come up with. And it was then that I realized that the lines are parallel, which means they're not going to have any solutions in common. So this is an example of no solutions. In the last problem that I would be modeling for the kids, the equations get even more complicated. I simplified them and rearranged them so that I ended up with y equals 1 plus x. And over here, when you combine the -2 plus the 3, you get +1. So these, as you can look at them, are going to be the same thing. So when we plug the x's in, we get the same exact y value for each of the x's. This is an example of 2 lines that are the exact same. So I did the first line in blue. I don't know if you can see that very well. And then I graphed the second one using a pink marker, and the kids will be able to see that any point that I pick out on that line at all is going to be a solution for both of the equations. At this point, I would move into guided practice. I would have small coordinate graphs run like the ones that you're seeing, because it is very difficult to draw your own coordinate graph and graph it and have it come out right. So I would then present each of the following problems one at a time. I would have them do it on notebook paper, give the equation, and then tell them step by step what they should be doing, what they should be thinking. In this first example, the equation on the right would have to be simplified. So I rearranged it to where I have a y equals 3x and a y equals 3x plus 4. When choosing my x's to substitute in, I worked the problems out here so that they could see, this is actually for this problem, so that they could see what exactly happens and how you work down your answer to find the y. After the kids finish this, hopefully that they will find that they have parallel lines, and hopefully as a class we can talk about the fact that that means that there are no solutions. No one exact set of x and y coordinates will be found in both lines. Another example that I would give the kids is this system of equations, and as you can see, the equations are even more difficult, more to simplify. Once I have worked through and shown them how to do that and make sure everybody understands that, then I would choose an x coordinate for each problem and work the problem so that I know the y. And when I go through all of this for both equations, you can see that the line ends up on top of itself, just like the problem that I had modeled earlier for them. All of the x's in this case will give you a matching y for that x. So that means that this system of equations have infinite solutions. One more guided practice, and that's a more simple looking set of equations. Again, substitution method, find the y. You will see that there's only one set of coordinates that both equations have, and that means that that one spot is the only solution and that these lines intersect. Before I would do independent practice, I would put up a poster that I made that summed this lesson up so that, again, they have a visual of what we're learning and they can use it constantly as they're doing their independent work. Because this lesson was rather long, if time does not allow, then we will pick up where we left off today in tomorrow's class, and we would probably begin with doing some independent practice. So here's another example of a poster that you might find in the classroom. This one is talking about the 3 different solutions for systems of equations, which is the lesson that I just presented. You'll notice that if the lines intersect that you have just graphed, that means there is one solution only to that system. If the lines run parallel when you graph them, that means there is no solution for the equations. And if the lines are exactly the same, they will lay on top of one another, and that's when you have infinite solutions. So there you have it. A sample lesson on how I would teach that systems of equations have 3 different outcomes or solutions possible. I hope you understood it. I would hope that the kids would understand it, but I would find that out probably a couple of days later by giving some sort of quick little quiz. And of course, from there, I determine, yes, we can move on, or no, we've got to back up and work some more together and perhaps some more independently as well to make sure that they understand everything that they were supposed to have learned. That's it. I hope you enjoyed it. I look forward to hearing from you.